Hey guys, this is a little help for your rectangle investigation worksheet. We are going to graph these 8 lines and in the indicated color. So basically, if I was you, I would do them in pencil first and then go over them with a crayon or a marker in that color. And I'd use a crayon because the marker might bleed through your paper and then you won't be able to see the backside very well. And then you're going to find a rectangle somewhere on your paper. Now, before we move on, I just want to put up here the definition of a rectangle is it must have 4 right angles. So that is what a rectangle is. So we're going to look for something that's got 4 right angles. And the only way that we can make right angles is to have perpendicular lines. And we've been talking about perpendicular lines in class. And perpendicular lines have opposite and reciprocal slopes. So that's kind of what we're looking for. Let's graph these lines and see if we can find a rectangle, and then we'll shade it in. Okay, in red, we're going to graph the line y equals x plus 2. So in this case, the last number is a plus 2. That's a free point of 0, 2. So that's where we're going to start, because that's the y-intercept. So on that point, x equals, or at the 0, 2 point, we're going to make a dot at 0, 2. Now this slope has a slope of 1. And if we want to make it a fraction, we could put 1 over 1. And that would be our slope. So that means we're going to rise 1 and run 1. So from this dot right here, we are going to go up 1 and over 1. And we're going to do it again. We're going to go up 1 and over 1. And we can do it again, and we'll go up 1 and over 1. And then we're going to draw that line in red. Whoops. Okay, that's the one I want. Okay, so we draw that in red. And I would suggest that you draw it all the way across your paper. Just make sure you line it up, because you don't know where the rectangle is going to be. Rectangle could be anywhere, so let's drop most of the way across your paper at least. Now let's go to the green one. The green one has a point of 0, -6. So that's our free point, 0, -6, because it's got the -6 at the end. So let's go ahead and find a point. Let's see. At 0, -6. That's way down here at -6. 4, 5, 6. Okay. And again, the slope is a 1. So it actually has the exact same slope. Imagine that. Same slopes. Wonder what same slopes are called. Oh, wait a second. We just talked about that yesterday. Same slopes are called parallel lines. Ooh, that might be part of our rectangle, because we know rectangles have 4 right angles, but we also know that rectangles have parallel sides, opposite of each other. This one has to be green, so let's make a green one here. Okay, let me extend that all the way across. Okay, the next one is the brown one. I'm going to make these a little smaller. This one doesn't have a plus number, so we could actually put a plus 0, which means really we have the point 0, 0. So 0, 0, that's where we're going to start on this one. Let me see if I can grab one of these points. Okay, so 0, 0. Now this is at a 2, and that's like a 2 over a 1 if I wanted to make a fraction out of it. It'd be like 2 over 1, which it means go up 2 and over 1. So from this point right here, I'm going to go up 2 over 1. I'm going to do that again. I'm going to go up 2 over 1. Do that again. I'm going to go up 2 over 1. And I'm going to color that in brown. Okay, so let's draw that in. Get my line. And I want to go brown. Okay, so let's color that one in brown. That has a slope of 2. Now you can probably see that that one's steeper. If you were in business, that would be a good slope because your business profits would be going up fast. So that would be nice. That is a steeper slope than the one. That's a slope of 1. That's a slope of 2. That things are going up twice as fast as they are in these. So, all right. Orange is a +4 at the end. Ooh. So that's going to be the point 0,4. So we're going to start at 0,4 in the orange line. Let's see if I can grab a point here. Okay, 0,4 will be right here. Now this one is a negative x, so that's -1. So it would be like a -1/1. So we could put a 1 under it again and make a fraction if we wanted to. And that's going to be just going down 1 and over 1. It's a negative slope. Negative slopes always go down. So we would go down 1 and over 1. That's already, we'll put it there anyways. And then we're going to go down 1 and over 1. Again, we'll go down 1 and over 1. And that one is going to be an orange line. So let me grab orange and draw that one in. Again, you can pause it on your phone if you're watching this on your phone or computer. If you're needing to go get other colors, you can always pause the video and go grab other colors and stuff. But this kind of looks like a 90-degree angle to me. Wonder if that's going to be part of a rectangle. All right, that was orange, so 4 down, 4 to go. Let's go to blue. Blue again ends in 0,4. Ooh, 0,4. We know what 0,4 means. It means we go, or +4 means we go to 0,4. I think we already started one at 0,4. Yeah, right there, the orange one. We're going to go to 0,4. And we are going to go up 2 and over 1. And again, we're going to go up 2 and over 1. And again, one more time, we'll go up 2 and over 1. And then I'm going to draw that one in blue. Dodger blue would be Royal Dodger blue. Okay, so that's going to come down like this. Look at that one and the brown one. Those two lines both had a slope of 2. Those are parallel also. Those are in the exact same direction. So definitely parallel. Stay in the same distance apart, and they have the exact same slope. All right, let's go to the next one. Yellow, 0,9. All right, that's going to start way near the top at 0,9 because it ends in a +9. That's our y-intercept. And it's a -1/2, so I'm going to go down 1 and over 2. -1/2 slope. So let me grab a dot here. I got to start at 0,9. And this is telling me to go down 1 and over 2. Down 1 and over 2. Down 1 and over 2. And I need to grab yellow and draw that in. That looks interesting as well, because that one seems to be making a 90-degree angle with blue. Kind of looks like a 90-degree angle right there, and with brown, huh? Alright, moving on to our last two. We got purple. Purple is going to start at 0, -6. That's going to be our free point, 0, -6, because it ends in a -6. Now it's a -1 slope, just like this one was -1, the orange. So it's -1/1, so it's going to be the same direction as orange. Purple and orange both have a -x. They both have a -1 slope. So I need to grab a point. I need to start at 0, -6, which we already did once. And we need to go down 1 and over 1. Down 1 and over 1. down 1. That would be a -1 slope. That one's got to be purple. So let's draw that one in. Oops. Okay, so there's our purple line. And we have one left, a black line, and that would be at 0, -5 is where we're going to start. That would be our beginning point, 0, -5. And that has a slope of -3 over 1. If I wanted to put this 1 underneath here, -3 means go down 3 into the right 1. Down 3 into the right 1, but I need to find the point 0, -5 first. So 0, -5 is right there. And then from that point, I'm going to go down 3 to the right 1. I'm going to do it one more time because I'll run out of room. Down 3 to the right 1. And that line has to be black. Okay, is there a rectangle on this page? And the answer is yes. We're looking for perpendicular lines. We already noticed some parallel ones. So blue and brown were parallel, and orange and purple were parallel, and red and green were parallel. But the rectangle has to have perpendicular slopes, opposites and reciprocals. And I'm looking at the purple, the red, the orange, and the green right in here. And I'm seeing a rectangle. Unfortunately for me, with a mouse, I'm not going to be able to shade that in very well. I'm going to try though. Okay, it's going to look like this. You guys hopefully can shade it in nicely in a different color or something. But it's this rectangle right in here. That's where your rectangle would go. And now there's some questions that we need to answer about that rectangle. And you can pause the video to finish your picture and stuff like that. I'm going to move on. Okay, examine the 8 lines that you graphed. Which 4 equations created the rectangle? Okay, so we said it was purple and red. So purple, well, red was y equals x plus 2. So let's write that one down first. Okay, so y equals x plus 2. Oops, that was one of them. Second equation we said was, that was red. Green was the same line, it's the opposite side, and it was parallel. Green was x minus 6. Y equals x minus 6. And you notice we'll put these two underneath each other because they both have a slope of 1. Okay, so those are two parallel lines. And then we move back to this side, and we're going to look at red. No, we did red already. We're going to look at purple. Purple, y equals negative x minus 6. Y equals negative x minus 6. That was purple. And then the last one would be orange, and that was negative x plus 4. Y equals negative x plus 4. And I'll put these two underneath each other because these both have a -1 slope. And if you were to multiply the slope of the first one times the slope of the second one, you would get -1. And slopes that multiply and equal -1 are always perpendicular. So these two lines are perpendicular to these two lines. So that's what makes our rectangle. How can you prove the shape that you drew is a rectangle? Definition of rectangles that has 4 right angles. Well, list the 4 slopes. Above, you've got a slope of 1, another slope of 1, a slope of -1, oops, and another slope of -1. What proves that those 4 slopes make a right angle? Because 1 times -1 equals -1. slope and perpendicular slopes have a product of -1. Product means answer to a multiplication problem. And so we can put A are opposites and reciprocals. That's what makes them perpendicular. What are the coordinates of the endpoints of the rectangle we drew? Okay, so let's find our points. Okay, one point is 1, 3. 1, 3. 1, comma 3. That was one point. Next point we have is 5, -1. 5, -1. Oops. Okay, another point would be down here at 0, -6. And the last one would be at -4, -2. -4, -2. Yep. -4, -2. Alright, let's go on, moving on. What is an equation of a line that would make a second rectangle in which the entire rectangle would fit into quadrant 1? List the slope and prove it's a rectangle. Alright, well let's look in quadrant 1 as this quadrant right here. So if we just focus our attention in this quadrant right here, and we're just looking right here, we need to find a place where we could possibly draw another rectangle. So at first we need parallel lines, and I see some parallel lines here, red and green, but this one is down here in the fourth quadrant, and that won't work. But I see blue and brown. I think yellow makes a perpendicular. And so if I drew another line, let's say we drew a, what color should we use this time? Burgundy or something like that. Let's say we used and made another line that looked, oh, I don't want that. I don't want a rectangle. Okay, that maybe went like this. Okay, I'm going to show you what it is here in a second here. What I just did was I made a line parallel to yellow. Yellow is a -1/2 slope. So what I did was I made a point, and I could have chosen a different number here, but I just went at 7. I went at 7, and then I just went down 1 and over 2, just like yellow. Down 1 and over 2, just like yellow. And I stayed on that line. And lo and behold, I made a rectangle in here. Boom, 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 right there. So it's got two parallels, and it's got two parallels, oops, my bad. And it's got two parallels this way, and it makes a rectangle, and those are right angles. So this would be the rectangle right here. Let's see what equation I just made. The equation I just made has a +7, and it's got a -1/2 slope. So the equation that I just made was y equals -1/2 x -1/2 x plus 7. Now that's not the only equation. I could have put a +6, a +5, a +8. Any of those will work. The slopes are going to be a -1/2 for the two lines, and the other slopes are +2's. Go back here. -1/2 and +2. And when you multiply -1/2 times +2, you equal -1. And it's a rectangle because your opposite sides are parallel, and adjacent sides are perpendicular. They have opposite and reciprocal slopes. So that's why it's definitely a rectangle. Now find an equation that would make your rectangle from number 1 into a square. How do we know that it's a square? Talk about slopes and sides. Be sure to prove your statements. Let's just take a look at our picture again. And this original rectangle is a rectangle. If you were to count the diagonals here, you get 1, 2, 3, 4 diagonals. Here you get 1, 2, 3, 4, 5. So this side is a little longer than this side. If we were to make another line, let's make it in, say, light blue maybe, aqua. And let's say we were to make a line that was the same as orange. Same line as orange, but it was down 1. So we just slid this down 1. Had the same slope, a -1 slope, but we went this way. We were down 1 line. That would change everything about our rectangle, because now the rectangle would have, this side would have, oh wait, hold on, I didn't go down 1, we gotta go down 2, gotta go right to there, there we go. Alright, so we went from 4 down to 2, but that changed everything. It was 1, 2, 3, 4, 1, 2, 3, 4, all the sides are now the same. They're all 4s, and the slopes are still perpendicular. So the equation of that line was going to be y equals -x plus 2. Y equals -x plus 2 would be our equation. Now, it has to be a -x, because we need it to be parallel to the orange or parallel to the purple. That would also be fine. But it has to be inside. It has to be either be a +2. There's one other possibility. We could have come down here and it could have been a +4 or -4. So either +2 or -4. That would have made the square on top. So either +2 or -4. Oops. So we could have also used the equation y equals -x minus 4. That would have also made a square. Why it is a square? Because all sides are equal and all angles are right angles. Now as you get into geometry, we prove more of this stuff. We could prove with distance formula that the sides are all the same length. We could prove with the slope formulas that they're all the same, they're all right angles. But that's what we're going to put down right now. We're going to put that these are all 4 equal sides, and our angles are 4 right angles. All right, see you guys later.